I'm excited that you are joining me today to learn a little bit about rate, proportions, and percents. So this is going to be covering topics in the standard 1.1D for Algebra 1. And if you are practicing in Study Island, you are going to want to use the topic rate, proportion, and percent to get the correct questions that align with this video. So remember, as you do, our study tips for these videos is you want to rewind, pause, and fast forward as you need to. And then make sure you're taking notes and writing the problems out. And if I go too fast, just press pause so that you can catch up. And you can also pause, work the problem out, and then press play so that you can check and see how you did with what I show you. So some ways that you might use this is the percent I use all the time while I'm shopping to try to figure out what is the best deal if something's on sale, if I'm trying to stay in budget, what it actually costs with the additional percent off. And then like a rate is like your miles per gallon. When you're filling up, if you're trying to figure out if your vehicle is performing adequately. And then proportions, if you're into building models or looking at models, or you see a model of something at a museum, that's all scaling. So anything that you're working with scaling is you use proportions to figure out correctly. So I'm looking forward to working with you today, and we're about to start.
Here is our first example question. Paul wants to beat the school record of eating 140 hot dogs in a contest. He has eaten 21 hot dogs so far. If he can eat 14 hot dogs every 2 minutes, how many minutes will it take him to eat the remaining hot dogs needed to tie the school record? So here's a picture of 14 hot dogs. This is how many he can eat in 2 minutes. So we are working in the rate, proportion, and percent section. So we're going to use a proportion to set this up. A proportion is simply a fraction equal to a fraction. But the first step we want to do is we already know he's eaten 21 hot dogs. He wants to eat a total of 140, and it's asking about the remaining hot dogs. So the first thing I'm going to want to do is subtract 140 and 21. So 140 minus 21 is 119. And that's how many hot dogs, HD, he has left to eat. All right, so in this problem, they give us the ratio of 14 hot dogs every 2 minutes. So I'm going to go ahead and set up my proportion. And I'm going to put 14 over 2. That's my first ratio. So I'm going to go ahead and label that's 14 hot dogs. So I'm going to just write HG off to the side and 2 minutes. So I'm going to write min off to the side just to help me remember what those numbers are. And the reason for that is because when I write my other fraction, my other ratio on the right side, I have to keep everything lined up. So I have 119 hot dogs left. Because I put the hot dogs in the top on the left, I have to put hot dogs in the top on the right. I have to keep everything consecutive and consistent. So 2 minutes, my time is on the bottom, and it's asking how many minutes. So that's what I'm looking for to solve. So I'm just going to put my X in the bottom to represent what I'm solving for. When I solve a proportion, we solve by cross multiplying. So I'm going to take 14 times x, which is 14x, equals, and then I cross multiply the other way, 2 times 119, which equals 238. And I ran out of room, so I just rewrote my problem over here. And my last step is going to be to divide both sides by 14. These 14s cancel, and I'm left with x equals 238 divided by 14 is 17, and that's going to be 17 minutes. So if he keeps up that pace, our answer is going to be B, 17 minutes. Question number 2 reads, Samantha is on her way to Oklahoma City. She drove 70 miles per hour for 3 hours and 30 minutes before she was slowed by construction. Then she drove 25 miles per hour for 50 minutes in a construction area. How far has she driven? Well, remember MPH, that stands for miles per hour. So in 1 hour, she goes 70 miles. And then when she hits the construction, in 1 hour, she goes 25 miles. That's what mile per hour means. So here, they give it to us in hours and minutes, in 50 minutes. Because this is mile per hour, we're going to want to get this into straight hours. So it's only in 70 miles per hour. That per hour is a ratio. So we're going to end up doing 2 proportion problems here. So first I'm going to do the 30 hours in 30 minutes. 30 minutes is I'm going to go over top of 60 minutes because that is how many minutes there are in an hour. 30 divided by 60 is 1/2 or 0.5. So that's 30 minutes is half an hour, which makes sense. And so that means for the 70 miles per hour, she drove 3.5 hours. Okay, and then the same for the 50 minutes. There's 60 minutes in an hour. 50 divided by 60 is 0.83 repeating. Or that's the same, it reduces to 5/6. So she drives through the construction zone of 25 miles per hour for 5/6 of an hour. So now that we have those set up, we can go ahead and set up our proportions. So for the first part, she's going 70 miles in 1 hour. Okay, and when we decided she traveled 3.5 hours. So we want to know how far did she drive in those 3.5 hours. So that's how I'm going to set up my proportion. Once again, this is my ratio. I keep that together on the one side. I keep miles on top and I keep hours on the bottom. I'm going to set up the next proportion the same way. Okay, in this one we know that she's driving 25 miles in 1 hour. And I want to know how far she's driving, so I'm going to put X on the top because that's where my miles are. And if you're using a calculator with a fraction button, I would go ahead and keep it 5/6. If not, you can use the 0.83 repeating here. And see here, I had to have it in hours on the bottom. I said to keep it in hours and hours. And you could have done it in minutes and minutes, but just to be consistent, I did hours and hours. Another reason to keep the 5/6 here instead of the decimal is because if I look at my answers, they're all in fraction form. So that's another reason I want to keep this as a fraction. So I'm going to go ahead and solve each proportion. Remember, I'm going to cross multiply. So here I'm going to have 1 times x, which is x. And then I'm going to have on the other cross multiplication 70 times 3.5. 70 times 3.5 is 245. So she goes 245 miles in that first part. So I'm going to go ahead and do the same thing on this side. I have 1 times x here. So it's going to be x equals. And then the other way I have 25 times 50, or 25 times 5/6. If you have a fraction button, you can go ahead and do that, or you can work it out long ways. And that's going to be 20 and 5/6 miles in the construction zone. So to find her total miles, you're just going to add those two together. 245 plus 20 and 5, 6 is going to be 265 and 5, 6, which is the answer C. Problem number 3. A radio station gave away 101 tickets to a concert. They gave away 2 times as many tickets to listeners as they did employees. How many tickets did they give away to employees? All right, so here I have to find my ratio. Now this one I have to actually think about, but they don't actually spell it out for you like they did in the problems before. Here, this is talking about total tickets. Over here, they're telling you it's 2 times as many tickets to listeners as employees. So that means for every 3 tickets they give away, 2 are going to listeners, 1 is going to employees. So that's how I'm going to find my ratio there. It's asking for how many employees, and it's also it's asking me how many employees out of these total tickets. So that's how I know those are the 2 types of numbers I'm going to need to set up my proportion. So I'm looking for how many do employees out of that 111. So then this ratio that it gives us here, 2 times as many as listeners as employees that I was talking about before, that's talking about a total of 3 tickets. And for every 3 they give away, 1 of those goes to an employee and 2 of those goes to a listener. So that's the ratio I need to set up on the left in order to solve. So I'm just going to cross multiply. X times 3 is 3x. 111 times 1 is 111. And then I just divide both sides by 3. And x equals 37 tickets, which is answer letter B. Mark buys a stereo for $253 plus 3% sales tax. He wants to sell the stereo for 15% profit over what he paid for the stereo. What should his selling price be? All right, when you're working with percents, you have to know how to convert them to decimal. So there's 2 ways. Pick one that works for you all the time and stick with it. So let's look at this 3%. 3%, you can either divide it by 100. 3 divided by 100 is going to be 0.03. Or another way that you can do it is you can remember that you need to move the decimal 2 spots to the left. So then when I move this one 2 spots to the left, I'm going to have to put in my filler 0, and that's also going to be 0.03. So either way, 3% converts to the decimal 300ths. All right, so what I'm going to do this is, first I have to find out how much tax that's going to be. So I'm going to take, my first step is going to take 253, what he buys it for, and calculate how much tax he's paying. So when I do that, I have to multiply it by the decimal form of 3%, which is this 300ths. So 253 times 0.03 is $7.59. So that's how much he pays in tax. So the cost of the stereo plus tax is going to be $260.59. That's what Mark pays for the stereo. Now he wants to resell it for profit, and he wants to make 15% profit. So I'm going to go ahead and find out what 15% of 260 is. When I do that, I'm going to have to convert 15% to a decimal, which is 0.15, and multiply that. When I multiply those two numbers, I get $39.09. That's how much he's going to make in profit. So to find his selling price, I'm going to take that $260.59 and add it to the profit that he wants to make. And when I add those two numbers, I get the final answer of $299.68. That's what he needs to sell it for, his stereo, to make a 15% profit. So his selling price should be letter C.